SciCuriousID presents. Picture this. Ancient structures like the Pantheon in Rome, completed around 128 Anno Domini, standing strong and majestic for nearly 2,000 years, defying relentless time, harsh weather, earthquakes, and relentless elements. Now, contrast that incredible endurance with our modern concrete buildings and bridges, which often start crumbling, cracking, and failing within just 30 to 50 years. This isn't nostalgia. It's a paradox of modern engineering. How did ancient Rome build concrete that outlasts our most advanced materials today?
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Concrete is the most widely used material on Earth today, with a staggering over 30 billion tons produced every single year, fueling everything from skyscrapers to sidewalks. Yet, this ubiquitous powerhouse is also a massive CO2 emitter during production, and despite its dominance, it cracks and degrades like my ambitious New Year's resolutions after the first week of January. At the heart of modern concrete is Portland cement, a fine powder made by heating limestone and clay, then grinding it with gypsum. When mixed with water, it forms a calcium silicate hydrate gel, or CSH, that hardens into a solid mess. However, once this CSH gel fully sets, it becomes largely chemically inactive and inert, so any microcracks that develop from stress, shrinkage, or environmental exposure just keep propagating and widening over time, compromising the entire structure's integrity. The clever Romans crafted their revolutionary opus cementitium using a smart recipe of lime, volcanic ash called Pozzolana sourced from places like Pozzolana near Naples, and often seawater for mixing, yes. They intentionally used ocean water, giving their concrete that extra salty attitude. Roman architect Vitruvius even specified precise ratios, like 1:3 lime to Pozzolana for general construction and 1:2 for underwater work, blending it with aggregates like rock, tiles, and rubble for unmatched strength. The true magic ingredient was pozzolana, packed with reactive silica and alumina that kick off a pozzolanic reaction with calcium hydroxide from the lime, continuously forming fresh calcium silicate hydrate and aluminate compounds over centuries, keeping their concrete chemically alive and evolving like zombie concrete that just won't die. This ongoing reaction fills voids, densifies the matrix, and builds strength progressively, turning their builds into time-defying powerhouses. Cutting-edge research has unveiled Roman concrete's astonishing self-healing superpowers. When water seeps into a crack, it activates small lime clasts, tiny quicklime fragments from their hot mixing technique, triggering a reaction that creates a calcium-saturated solution, which recrystallizes into calcium carbonate crystals, sealing the fissure shut just like frost creeping over a window pane. No ancient myths here, just pure, brilliant chemistry in action that keeps structures watertight and robust. Especially when mixed with seawater, this process sparked the growth of rare aluminous tobermorite and philipsite crystals, which are aluminum-rich and silica-poor compared to natural versions, interlocking and densifying the concrete matrix to make it even stronger with age. These unique crystals turn time from a destructive foe into a powerful ally, enhancing durability against fractures, corrosion, and marine assaults over millennia. So why did we ditch this superior Roman recipe? The 19th century industrial boom demanded lightning-fast construction, and Portland cement, invented around 1824, delivered quick-setting convenience ideal for rapid urbanization, but sacrificed that legendary long-term durability for short-term speed. Did you know the Romans poured this magic mix into wonders like the Pantheon, whose massive unreinforced dome, the largest in the world, still stands pristine after nearly 2 millennia, using lighter tuff and pumice aggregates at the top to ease stress? Meanwhile, many modern bridges and dams struggle and decay after mere decades, mind officially blown. Modern reinforced concrete battles nasty issues like steel rebar corrosion from water, salt, and air infiltration, plus sulfate attacks, lime leaching, and alkali aggregate reactions that crack and weaken it over time. But excitingly, Scientists are now reviving Roman techniques with pozzolanic additives and hot mixing for self-healing, lower CO2 emissions, and vastly improved longevity in our builds. By rediscovering this ancient wisdom from structures like still-flowing Roman aqueducts and the seaworthy harbor of Caesarea Maritima, we can forge a sustainable, ultra-durable future for construction. Hit like and subscribe for more hidden gems of science and history.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.